Okay. Okay, so for part B, we're gonna find the 8th term of the geometric sequence. They give you A3 and A5. So the first thing we're gonna do is find the common ratio. And remember, I'm showing you how to do this with the formulas. Okay, and then there may be shortcuts that you guys discover along the way, and that is perfectly fine. Okay, so if you want to figure out the ratio, okay, so this is a sub n equals a sub 1 times r to the n minus 1. Okay, so then what we're going to do is plug in the two terms that we know. Okay, so we know a sub 5 and we know a sub 3. Now this is a little different from the first one because now we're going to get r squared. So we're going to have to solve using square roots. And then just remember, whenever you take the square root, you're going to have plus or minus with it. Okay, now that's going to change what step 2 looks like. So now for step 2, when you're finding a sub 1, you're going to consider both the positive and the negative values. Okay, so for both of them, you're going to use the smaller number. And for your positive one, you are going to plug in your 3, your value for 3. Okay, so then A3 equals a sub 1 times r to the 3 minus 1. Okay, which is, you know our r value is positive 3 now. Okay, you've given that that's 36, and then you're just going to solve. Okay, so your a sub 1 for this is going to be 4. Okay, for the negative, we're going to do the exact same thing, but now you're plugging in r as negative 3. Okay, and in this case, you happen to get a sub 1 equals 4 again. Does anybody think about a time when they would not be the same? Yeah, go ahead. Exactly. Okay, yeah. So when this exponent is an odd exponent, then that would change it. So I put odd exponent, but what Matt's saying is correct. Like if you're trying to find like an even term, then that would make the exponent odd. Okay, and then after you find those, you also have to consider both cases for step 3. So once you consider both cases for step 3, you're going to plug in for the positive, the first term, and r is 3. For the negative, you are going to plug in 4, and then r is negative 3. Okay, so if we look at the positive, you're going to use a sub 8. They're telling us to find the 8th term. That's why we're using 8. Okay, so if we do 8 minus 1, we get 7. Going to be 8,748. And then when we plug in the negative, just like you guys talked about, because this is odd, you're going to have a negative number. So your solution is going to be plus or minus 8,748. Okay, the next thing we're going to talk about is the partial sums of a geometric sequence. So this is your formula. Okay, don't worry if you didn't get everything written down. I'll put it back up. Okay. So with the partial sums, what you're going to do is use our partial sum formula for a geometric sequence, which is a little different than the one that's the arithmetic. So, for example, for part A, they ask you to find the sum. If we're going to find the sum, we have to know the number of terms. But we don't know the number of terms for this one. So what I did is I labeled these. I knew that this was A1, this was A2, this was A3, and then this would be called A sub n. Okay, so for step 1, you want to find the common ratio, and you want to figure out your n for how many terms there are. Okay, so to find r, again, we're just going to use A2 over A1, which is going to be 2. Okay, and then to figure out n, what I'm going to do is use the new formula that we talked about today, a sub n equals sub one times r to the n minus one, and I'm gonna plug in what we know. So I know that a sub one is one, I just found that r was two, and I know that a sub n term is 256 from our sequence here. Okay, so what I can do is I can solve this. Now, even though this is one, I'm gonna show you how to do this just in case it wasn't a number, because people forget to do the order of operations a lot. You would wanna divide by this number first, so when you divide by one, you get the same thing. Okay, and then, does anybody remember how you can undo a base of two? Yeah, take the logs, good. Okay, so what I did is log a base two on both sides. And then you can use this on your calculator. If you have the change of base, you can do that. If you don't, do you guys remember the change of base formula? Yes, and so it'll be the log of 256 over the log of 2. Okay, so you should get 8 from that. Okay, so if you get 8 equals n minus 1, your final answer is going to be n equals 9. So that means in step 2, you're gonna find the partial sum of s sub 9. And then in your formula, you're gonna plug in s sub 9 equals, this is a1, and then 1 minus your r value to the 9th, and then 1 minus your r value on the bottom. And then you should get 511. So just double check to make sure that you got the same thing that I did.